Hi there. In today's screencast, we will build a broken links application. What this application is going to do is it's going to look at a page and try to find broken links on that page. So to start off, we will use this as an example page, and uh, what we have here is we have two links. One which goes to google.com, which is a valid link, and another which goes to /foobar.com/blah, which is a broken link. So given this URL, our application should find a link called fooey, which is broken. This way, site owners can find out broken links on their websites and fix them, thereby making the web better. All right, so this is a very good problem to solve with a Phoenix application, and we'll see how that's done in this screencast. All right, so let's get started. The first thing we need to do is create a new Phoenix application, and since this application doesn't have a lot of stuff to store, we will skip. Uh, so to build a new Phoenix application, we say mix Phoenix new and give it a name. So we'll say broken links is the name of the application, and we'll also say this doesn't need ecto, which is the ORM. So we are saying we don't need a database to store any info, and uh, we'll also skip brunch, because right now we're going to say we're keeping it simple. All right, so we may add that later, and for now we don't need branch or ecto. And so the first thing we need to do once we get into this directory is init a new git repository, add whatever uh, files we have, and create a commit here. Okay. All right. So now that we've done that, I'm gonna open a tmux session here and open my editor. And so since this is a very straightforward project, I'm not going to create a to-do list of things, uh, but and just get started with the application instead. Okay, so I'll create a new tab and open a mix console here. So it's compiling the files which we just downloaded. Until then, let's just actually write out what we need to do to get this working. So to get this working, we first need to go to the page. So programmatically, when I say go to the page, what we need to do is download the HTML of the URL, right? So that's what we need to do first, and then we need to parse out the links from the first step from the downloaded page, right? So we need to know which ones are the links, right? Fooey is a link, Google is a link, more stuff is not a link. This is text, right? So we parse out the links from number one, and then we try to visit these links, right? So when I say visit, we try to download uh, the HTML for the links, right? So try to download HTML for the links from two, right? And if it fails for a link, it means that link is broken, right? So very simple. We've just documented the steps which we would manually do into a nice algorithm kind of list. Okay, so let's go back to IEX, and we see that we have a terminal here, and why did we get into this IEX? Because I'm forgetting this. Anyway, so let's get started. Okay, and the first thing we want to do is open a web server. So to do that, you can do mix Phoenix server, and that should open up our server at localhost 4000, and I can go to localhost 4,000 for that. So this is a nice page, right? And what we will do is, so we'll get started in a simple way. Uh, Before all of this, we need to allow the user to enter a URL, right? So for that, we'll create a simple page with a form, right? So let's do the simplest thing and put the form on this index page. Okay, so the form is in a file called templates page index. So that page, I'm sorry, not the form, the page, this page is in a file called index.html.eex. So what I'm going to do is I'm going to remove everything and put a form here. So I'll say form action is analyze, and I'll say method is post, and we'll have an input text box whose name is going to be URL, right? So URL, and we'll just put a placeholder here. I'll say enter the URL, right? And we'll also have a submit button here. We'll call it analyze or find broken links, right? So now we have a form, nice form, and when I enter something and hit enter, it's going to the analyze route, and it says I don't know what to do when I get a request for this, right? So we haven't told Phoenix how to handle this yet, right? And it says there's no route for this. So to fix that, we need to go to the router.ex file, and we need to put a route here. It says whenever you get a post to the analyze URL, what I want you to do is go to the page controllers analyze action. Okay, now we're doing this to do it in the simplest possible way, and actually instead of post, let's make it a get. Okay, so that is actually simpler. And what we'll do is if we go to the index.html template, let's remove that method, and by default it should be a get. Okay, so go back, refresh, and say foo.com, and now it says there's no route for analyze /get /analyze. So the reason for that is probably because the server hasn't been restarted. This is because we disabled branch, and it's not doing the auto compile thing. So now when I refresh this page, it says page controller analyze /2 is undefined, right? So that's good, we are making progress. If we go to the page controller we don't have the analyze action, so let me copy the index action and rename it as analyze, and I'll say it renders the analyze HTML template, and let's copy the index template and call it analyze. Okay, oh, so we actually, instead of copying it, we renamed it. So let me undo that. Alright, so now we have a template called analyze, and I'm gonna add a heading here called analyze. Alright, if I refresh this, still throws the same error. So let's restart the server. Right, so now we have a nice analyze page. Alright, now what we want to do here is we want to show the broken links, right? So the core of the application is something which takes a URL, right? Something which takes a URL and gives us a bunch of broken links. Okay, so I'm thinking that could be a module in the models folder. Okay, so let's create a module called page analyzer. Okay, and this module is going to have a method called analyze, which takes a URL and returns a list of broken URLs. Okay, so that's very clean. We just need a method called analyze, which returns a list of broken URLs, right? And for now, I'm just going to hard code a URL here called so I'll say text is what's the URL called, fooey, right? Say fooey, and I'll say href is foobar.com. Okay, so here what we're doing is we're saying it doesn't matter what you pass, I'm always going to return this link, right? So I'm just hard coding this stuff to allow me to actually see if we can render this. Okay, so we have a nice module, a nice method. Let's test it out. Okay, so we need to go to the page controller and analyze, and here in the params we'll get a URL, right? So I'll say we can do some pattern matching and get the URL into a URL variable, and here we can say broken links dot and page analyzer dot analyze URL, and this should give us a bunch of broken links. Okay, and here to the template we can pass a URL and a list of broken links, right? So that way, and once we do this, we can go back to the analyze HTML page template and say analysis for this URL, right? And for now we'll just put a bunch of list items. I'll say broken links and so the first thing I want to do here is we want to loop over all the broken links, right? So for that, let's see if we have a for snippet. Yeah, for broken link in broken links, right? In broken links, what do we want to do? We want to render a list item, and that list item is going to have broken link dot text and a broken link dot href. Okay, so that looks good. Let's give it a try after restarting our server. Okay, so now our server is restarted, and let me enter something here. So let me actually enter this URL, and it says analysis of this broken links foobar.com, right? Awesome. It seems like our code is working, but in fact it's not actually working because it's not really going to localhost :8000. So just to change things a bit, what I'm going to do here is behind the scenes I'm changing the index.html page to have another broken link called bar. Alright, so now if I refresh this page, we have a broken link called bar, right? And if I go back to the analyze application, the broken links application, it doesn't do anything, right? It doesn't detect the new change because this is all dummy code, right? This is all hard coded. So now let's do the actual work of building our analyzer, right? So let's open up the analyzer, right? Page analyzer, and let's open up our to-do file because that had a nice algorithm, right? So let's paste it here and use it as our guiding map. Okay, so allow the user to enter the URL, right? That we've already done. Download the HTML at this URL. So that's what we need to do here, right? So now to download the HTML, you can use Erlang's pre-built functions, or use an external library called HTTP Poison, which is a very nice library. So I'm just gonna show you how to use this HTTP Poison. Okay, so let's go to HTTP Poison, and when you go to this, it shows how to use it. You need to add it to the dependencies in your mix file. So let me do that. Open up the mix file and go to depths, and at the end of this I'm going to add the HTTP Poison dependency. Okay, and once we add this, we also need to run mix steps get to get this new dependency. So that's done, and once we do that and restart the application, we should be able to so let me open up mix console here. We should be able to use HTTP Poison to get the HTML for pages. Okay, so it's compiling a few things, and once it's done that, we should be able to use this to get the content of a web page. Okay, so let me run that, and it says exited in gen server, blah blah blah. Okay, so I'm not sure what the error is, but let's try to get a valid page. Example.com also seems like a valid page, but let me get content of my blog, and it says so it says exited in call Hackney manager, and the process is not alive, or there is no process currently associated with the given name. So this is usually happens when the application is not added to the application's collection. Okay, so so this was actually changed in Elixir 1.4, but seems like Phoenix hasn't done this. So one thing we can actually do is we can get rid of the applications and change it to extra applications, and just add logger to this. Okay, so let me restart this and paste that command, paste that function call, and it works. Okay, so that's nice. Elixir 1.4 has a nice change where you don't have to add each application in your depths to your applications list. You can just create an extra applications list and just list down the things which are not part of your normal depths there. Okay, so that fixes that. Now the way you download the contents of a page is by using this function from HTTP Poison. Okay, and so that thing is clear, and what it returns is it returns as an OK tuple, a tuple with the first element is OK, second element as an HTTP Poison response with a body, right? So let's go back to our page analyzer and put our code here, right? So http poison, instead of the hard-coded example URL here, say we'll use the URL here, okay? And we'll say if what we get from here is an OK and http poison response with a body, right? Because that's where it matches, right? So it's an http poison response with a body element, right? And it also has a status code 200, right? So let's add that. So actually I think this is fine. So I'll just say if it's an OK, if it's not an OK, we'll just return an error tuple, an error atom, okay? So looks good, looks good. And what we need is, so what we need is, we've downloaded the HTML of the URL that's contained in the body, okay? So for now I'll just print out the body. I'll just say inspect puts the body, and that looks good. Let's restart the server and go back to our page and refresh the page here. And if you see here, it's printing the body of the web page. So that's good. We've made progress. Now what we need to do next is parse out the links from the body, okay? So this is what we need to do. And to do this, there are a few ways to go about this. We know that the body, so if I go here, the body is a string, right? The body is a string. We can use some regular expressions to extract the hrefs and the text, but that's not a good way to go about it. So there are many libraries in Elixir which allow us to do HTML parsing very easily. So let me quickly search for HTML parse or Elixir, okay? And Floki seems like a good fit here. It has a good number of stars, so let's use this. And let's go to the documentation, see what we have there. Alright, so it says this is the current version 0.131. So let's go back to our mix file and add that dependency. So we'll say Floki and 0.131 and mix steps get to get the dependencies, and this is how it says you can use it, okay? So what I'm gonna do here is I'm gonna use our HTML, example HTML, put it in a string, right? So we'll copy this and restart our server. And I'll say HTML is triple quotes, right? Now Floki has a method which takes the HTML string and a CSS selector. So Floki find HTML, and the selector I'm after is the anchor tag. And this is very nice and neat. So if you see, it's giving us a list of tuples, 3 tuples, and each containing the name of the tag, the attributes, and the text inside of it. Okay, so that's very nice. So let's use that. Okay, so we need to go to our page analyzer and I'll say parse out the links. I'll say links is parse the body, right? And create a new method here called parse, which takes HTML and uses Floki dot parse to, sorry, it's not parse, it's find, to get all the links, right? And so we are assuming this is a simple page, so I'll transform that into so map. And if you look at the return tuple, it is contains three elements: the tag name, which is a, the attribute list, and the nodes inside of it, I guess. So what we need to do here is we need to say enum map, and I'll just say so I'll say function, and this is a 3-element tuple. So the first one is going to be a always, so we ignore that, and the second is a list of attributes, and the third is the text. So this is not a perfect match, because we'll see why it's not a perfect match in a minute. And what I want to do is, from those attributes, I want to find the attribute whose name, so I'll say key value, where key is equal to href. Okay, and from this I want to get the value, the actual href. Okay, so this should give us the href. And finally, what I wanted to turn from here is a map containing text is text and href is href. Okay, so parse should return a list of maps containing a text text element and an href element. Okay, text value and an href value. There seems to be an error here, and yeah, I think I forgot an arrow here, so that should fix it. So parse links should return a bunch of links, and what we want to do with that is number 3, right? We want to download all those links. So that's what we need to do. Undefined function parse, yeah. But at the moment, what I want to do here is just want to return OK links, and here, in case there's an error, it means the URL itself is broken, right? So I'll just return an error here. Okay, broken, or yeah, error is fine. And can say oops, and to inspect oops. Okay, so what I'm doing here is taking the error and converting it into a string and returning an error tuple. Okay, now if we go back to the page controller, here we're getting all the broken links, but this can also be so this is kind of a conditional. So so this can be one of two things. It can be OK broken links, right? In which case we render that, or it can be OK. It can be error message, in which case we will just show the error, right? So render text. So we'll just render the text with that message. That should, I'm sure there is a method called text. So let's try it out. So what I'm gonna do here is, let's see if we restarted our server. Let me do that again. So no clause matching href text fooey. Yeah, so it says there's an error here, and I think we're not returning an OK broken links tuple. And let's see where that is. So we'll go to page analyzer and OK links. Oh, so there's this at the end, so we are actually returning this. So let me remove that hard-coded thing. And now if we see, we have broken links where we're showing all the links, right? So at the moment we are returning all the links as broken links, right? So now if I go ahead and change my page, so I just removed the bar link, it goes away from our page here. So it's actually going and getting the HTML. So that's a good thing, right? That's a good thing. Now, but that's not enough. We need to do number 3, which is try to download HTML for the links from 2, right? So what we need to do here is, some of these links are good, some of them are broken, and we need to find the ones which are broken. So what we'll do here is we'll say links, we'll send them through a filter where we'll say we'll have a method here called broken link, which is going to tell us if a link is broken, and that is going to give us the broken links, right? So since this is a simple call, I'll just remove the pipe here. Say broken links is a filter over links, but where broken link is true. So what this means is we need to have a method called broken link, which takes a URL and tells us if a link is broken. Okay, and this again, for this again, we'll have to actually try and download the HTML, or whatever the content is for that page, right? So for now we'll just do it the simplest way. We'll just use http poison get that URL, right? And if it is okay, and we don't care about the body at this moment, we'll just return true. And if it is not okay, we'll return a false, right? So this can actually be, yeah, we'll refactor this later, but for now this is all we need to know. If when we made the request, did we get an okay or a not okay, or an error, right? That's all we need to know. And now if we restart the server and if we look at those links, it says throws a different error message, and let's see what's going on here. So this URL is not actually a URL. This is a map containing an href and a text, right? So we need to actually change this a little. We need to say this broken link gets a map containing an href and some text. We don't care about the text. So now I'm gonna stop this and restart this, and let's see what's going on here. Awesome. All right, so it's actually showing us the Google link. It says this is the one which is broken, and if we actually go to the page, we see 3 links. where Google is the one which is not broken. So we have some inverse logic somewhere. And here we're saying if HTTP Poison is able to get the link, it is not broken. So we need to invert this here. So it is a broken link if we don't get an OK, right? So now this looks good. Well, it's just a, yeah. So now if we refresh this page, it says HTTP Poison error. So it's yeah. So this is our error matcher. Okay. So now here it says bar is the only broken link. Let's see if I go to Floki. What kind of response is this? If you go to the network, I'll see it's a 404, which means, okay, so here there's another flaw in our code. In our code, what we're doing here is we're saying if we get an OK, even if it is a 404 error or a 500 status code, it's okay, is what we're saying. So we'll change that. We'll say when I'm getting an HTTP Poison response with a status code, right? It is okay if status code is less than 400. Okay, so what I'm saying is if it's a redirect or a 200 series code or a 300 series code, it's okay. If it's 400 or greater than 400, I'm saying it's not okay. Okay, because 404 is actually a broken link. All right. So with that change, let's restart our server. And now we should see two links here, bar and Fui. So it's a timeout again. Another timeout. Alright, so now we see two links, bar and this. So that's weird. Maybe we have another inversion here. So it's a broken link if it is greater than or equal to 400. Alright, so this kind of inverse logic is always prone to errors like these. Alright, bugs like these, logical bugs. So it's a broken link if the status code is greater than or equal to 400. Okay, so now if I restart the server, one thing which you may have observed is it's timing out a lot. Okay, and what we have is, alright, so now this is good, right? So it's giving us the right values. So one thing we've noticed here is it's taking a long time to load this page, and it's timing out often, right? Because our request only has so much time. So but this is good, right? We have our application working. It's able to find all the broken links on a page. So this is awesome, right? So what we are going to do here is we're going to stop for today, and in the next session we will see how we can use ETS to make this more interactive, in that, you know, we'll try to avoid the timeout issue, and we'll also allow the user to see broken links as they accumulate. And finally, this version of our app works only for single pages. So if your website has like 1,000 pages, you'll have to enter those 1,000 pages manually. So what we're going to do in the next session is make it so that it goes through all those 1,000 pages on its own without us manually entering stuff. All right, so that's it for this episode. Stay tuned for the next one. Goodbye.